OK, so what is this cusp that we've been saying the words for? We'll answer a couple of questions that have come up. Where's the cusp? So if we look back at our operator, we had this operator. And we could make a field redefinition, if you remember, and put the ultrasoft effects into a Wilson line. Now, for this heavy quark here, remember what the theory for that was with HQET. So the field theory for this heavy quark was an IV.D HV. And if we actually make a similar field redefinition to the one we talked about to get this Y, but on the heavy quark field, then we can actually, in terms of this guy here, get a free Lagrangian as well. So actually, all the effects from ultrasoft gluons in this operator can be encoded in Wilson lines. So if we do that, so that just says that actually, when we talked about static sources could also be encoded as Wilson lines, and by a kind of similar manipulation to what we did when we talked about SCT. So if we look at the ultrasoft sector here, we have a Wilson line. It actually has a path. So there's a Wilson line that comes from minus infinity along V to whatever position we put our operator at. Let's take it to be 0. And then we have a yn dagger, which is extending out to plus infinity from 0, like that. And the cusp is this fact that there's a kink in this Wilson line. It's not a smooth pass. It actually has a sharp angle. And that's the cusp. So there's actually a general renormalization theory for renormalizing Wilson lines with cusps. So this is something that at some point in the history of QCD, people tried to reformulate QCD in terms of Wilson lines, entirely in terms of Wilson lines. Then they realized that they could have these cusps in the Wilson lines, and the renormalization of that theory became much more complicated than the renormalization of the QCD action, because they couldn't prove that in general these cusps wouldn't come out of the dynamics. And then people dropped it. But along the way, anyway, they formulated a sort of a general renormalization theory of cusps in Wilson lines. And whenever you have a cusp like this, you end up having, in our language, this log, single log in the anomalous dimension. So if one of the lines here is light-like, and one of them is, because n squared was 0, then the anomalous dimension for this cusp will have a single log like our log of mu over w. So that actually holds not only to one loop, as we talked about, but actually to all orders in perturbation theory. If we'd gone to higher orders in perturbation theory, then what would happen is that the coefficient of that log would get corrected, but there'd still be only one log in our anomalous dimension. That's also something that you can argue from SCT directly, but sort of originally it falls from this general theory of the renormalization of cusps of Wilson lines. So if you were thinking about our calculation, you may remember actually that we got 1 over epsilon squared. It's from the ultrasoft diagrams, and that's in some sense what we've just talked about, because these are the ultrasoft diagrams, and they have 1 over epsilon squareds. There was also 1 over epsilon squareds from the collinear diagrams, right? So if you like, this piece here also, in some sense, has kind of a cusp. And in this case, it's not. It's actually what we're doing is we're taking a Wilson line, along the n bar direction, which is our Wn. And then we're attaching it to a quark field. Okay, so this is a full Cn quark field. It's not a Wilson line. So you could think of it as just ending on a quark field. But even just ending on a quark field, the quark field also has dynamics. It's not as simple as Wilson line dynamics, but it has dynamics, and we have interactions between these. And this is also kind of a cusp. Although it's not a simple Wilson line cusp, it's also kind of a cusp. Okay, so even the collinear graphs where the Wilson lines ended on quarks also produced these 1 over epsilon squareds and have this kind of structure, and they actually have very similar relations to cusps and regular Wilson lines. Okay, so that was one question. What was this cusp?